Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So as per the problem, determine the slope of the tangent to the curve at the given value of x. This equation y equals square root of 5x minus 1 represents the equation of the curve, and we have to find the slope of the tangent at x equals 2. For this problem, we'll have to use the formula for slope using the difference quotient expression. The formula is m equals limit h approaches 0 and then f at a plus h minus f at a over h. Now in this problem, the given function can be written as f at x equals square root of 5x minus 1, and the a value is equal to 2. So if we sub in a as 2, so f at 2 is equal to square root of 5 times 2 minus 1, which is equal to square root of 9, which is equal to 3. So f at a plus h will be equal to square root of 5 times a plus h minus 1, and if we sub in a as 2, so we'll get 2 plus h equals square root of 5 times 2 plus h minus 1, which can be simplified too, so we can distribute the 5, so we get 10 plus 5h minus 1, so which can be reduced to just 9 plus 5h under the square root. So this should be the expression we should use in the formula for slope. So in the next step, we can sub in the a value. So limit h approaches 0, f at 2 plus h minus f at 2 over h. We can sub in the expressions. So limit h approaches 0. So f at 2 plus h is 9 plus 5h under the square root minus f at 2, which we found to be equal to 3 over h. This is the expression we have to simplify, because if we apply the limit h equals 0, then the denominator of this expression becomes equal to 0. So as a result, the expression becomes undefined. So we have to figure out a way to cancel out this h in the denominator. So for that, we'll have to use the conjugate method. So as per the conjugate method, we'll have to multiply the numerator and the denominator by the conjugate of the numerator, because we have to simplify the numerator. So the conjugate is an expression with the same terms but with the opposite sign in the middle of the terms. So in this case, the conjugate will be square root of 9 plus 5h and then plus 3, and the same expression in the denominator, square root of 9 plus 5h plus 3. So in the next step, we can write limit h approaches 0 and then square root of 9 plus 5h minus 3 in parentheses times square root of 9 plus 5h plus 3 over h times square root of 9 plus 5h plus 3. Now we can simplify the numerator by using the FOIL method to distribute the terms. So we get m equals limit h approaches 0. So first we do square root of 9 plus 5h times square root of 9 plus 5h, which is equal to just 9 plus 5h. And now we do square root of 9 plus 5h times 3, which is equal to 3 times square root of 9 plus 5h. And now we do negative 3 times square root of 9 plus 5h, which is equal to negative 3 square root of 9 plus 5h. And lastly, we do negative 3 times positive 3, which is equal to negative 9 over h times square root of 9 plus 5h plus 3. Now we can cancel out like terms in the numerator. So plus 3 times square root of 9 plus 5h minus 3 times square root of 9 plus 5h cancel each other out. So we are left with m equals limit h approaches 0, then 9 plus 5h minus 9 over h times square root of 9 plus 5h plus 3. Now we can cancel out the 9's in the numerator. And now we can also cancel out the h's. So I can show you the step here. So limit h approaches 0, we get 5h over h times square root of 9 plus 5h plus 3. So now we can cancel out the h's because there is a single h in the numerator and the denominator. So now we are left with m equals limit h approaches 0, 5 over square root of 9 plus 5h plus 3. Now we can apply the limit. So we get m equals 5. So now we are applying the limit, so we don't have to write the limit expression. So 9 plus 5 times 0 plus 3, which is equal to 5 over, so 5 times 0 is 0, so which is square root of 9 plus 3, which is equal to 5 over 3 plus 3, and the final answer is 5 over 6. So this is the slope of the tangent to this curve at x equals 2. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.